A recent paper claims to have solved the enigma of rapid protein evolution. Now, I've talked about this in recent videos, and you can see the link to the paper down below. One of the problems that I pointed out is that the fitness function in this paper is forward-looking or teleological, so no wonder they were able to evolve realistic-looking proteins. But that's no fair, so a big problem right off the bat. Another problem I pointed out is that they assume the pre-existence of the genetic code, but the genetic code requires an army of proteins. So if you're trying to show how proteins first evolved, you can't be assuming the prior existence of an army of proteins. Now, their answer to that is that they are assuming a genetic code that doesn't use any proteins. It's free of proteins. It doesn't require proteins. But that's like a hamburger without any meat. It's never been observed. There's no such thing. So another big problem. Now, another problem is that they want to demonstrate the evolution of some functions. So they're trying to evolve a protein-protein interface. Proteins often interface with other proteins and form what is called a quaternary structure. And these protein-protein interfaces are important. They want to show how that could have evolved. But to do that, they have to assume what? The prior existence of a protein to which it will bind up to. The protein they are evolving will bind up to this other protein. They have to assume the prior existence of. So again, proteins are abounding all over the place here. Now, another problem with the paper is that they use artificial intelligence tools to predict the protein structure. So in other words, they are evolving these genes, they're randomly mutating these genes and expressing them and encoding a protein. So you have a random sequence, you mutate it a little bit, express that. What kind of a protein structure is going to come out of that? Well, they're using these artificial intelligence protein structure prediction tools. Well, so they're feeding these tools a random or near random sequences, but the tools have been trained on native or near native sequences. So they're using the tools far outside of their use cases, far outside of what is appropriate. Now, they are using a prediction confidence metrics, but again, the tools are way outside of their application, their region of application. So they really can't be certain of what they're getting when they ask the tool, what kind of a structure would this produce? A random or near random amino acid sequence, who knows what that's going to produce? I don't think the artificial intelligence tool is going to know very well. They certainly can't be very confident of that. So another caveat on the research. Yet they are very triumphant and they make high claims that they've solved this problem. Religion drives science, and it matters.